Swayam Prabha. Digital India. Educated India.
Let us see what an hydrostatic state of stress is. Hydrostatic state of stress. This is, if you immerse a body in a fluid, then it will be subjected to equal pressure on all surfaces, and such a stress state is called an hydrostatic pressure or hydrostatic state of stress. Okay. You will, if I were to write it in terms of the matrices, this will be P times 1 0 0 0 1 0 0 0 1, which is called shortly as P times identity matrix. Okay. This is called identity matrix, and is denoted by this symbol 1. Okay. So, basically now you have this sigma written as P times identity. So, what will be the Mohr circle for this? Next question is, what is the Mohr circle for this? The sigmas of n, taus of n. What is the Mohr circle for this? Basically you have sigma xx equal to sigma yy, and there is no shear stress at both the points. So, this will be a point on the Mohr circle, which will be P at a distance P from the origin. Okay. So, the Mohr circle is a point on the x axis. Okay. It is not a circle. What does that mean? It means that any plane will have no shear stresses on it. All planes will be subjected only to the normal stresses, which is P. Okay. So, what we are saying is, in a hydrostatic state of stress, there will be no plane, there is no plane on which shear stresses occur. Okay. In contrast to this, in inertial state of stress, there was a single plane on which there was no shear stresses. That was a plane on which you wrote the stress state. Your Ex, Ey axis that you chose, your Ex, Ey axis that you chose here was a stress state where there was no shear. That is, you represented these 2 points in the Mohr circle, but any other plane will have a shear stress, because this is a circle in here. Okay. In contrast, for a hydrostatic state of stress, there is just a point, there exists no plane on which there is any shear stress. This is a much stricter requirement than what happens in case of any other stress state. Okay. In any other stress state, there will be a plane on which there is no shear stress, but there will always be shear stress in some plane. Only if the state of stress is hydrostatic, there will be no plane on which there is shear stresses present. Okay. Now, the next stress state that we want to define is what is called as a pure shear stress state. What this means is, there exists a plane, on which only shear stresses act, that is, no normal stress on this plane, no normal stress on this plane. Okay. So, what does this mean? It means, if I take, let us assume Ex, E y, and let us draw the stress cube. In the stress cube there is only tau. Okay, there is only tau acting, there is no normal stresses on this plane, there is no sigma xx or sigma yy. Okay. If I write it in the matrix form, this sigma would be 0 tau 0 tau 0 0 0 0 0, okay, because the shear stress is sigma xy or yx stress. Okay. So, the sigma will be written in this form, the corresponding Mohr circle would be n taus of n, the corresponding Mohr circle would be the following. Okay. Circle will be the following. Now, what are these points? 0 and 0, tau and tau, right. So, the points that helped us draw the circle were these 2 points. Okay. The normal stress where the maximum shear stress occur is this point, which is 0, and there is no normal stresses in this plane, but there exists a plane where there is only normal stresses and no shear stress, right. That is this plane which is 90 degrees to this principal 90 degrees to the maximum shear stress plane, wherein in this plane this will be tau and this will be minus tau, if this were to be tau and tau. Okay. So, what happens if I rotate this by 45 degrees, because I have 90 degree rotation in the Mohr circle, I will rotate this by 45 degrees, rotate this by 45 degrees, so C x star E y star, which makes an angle 45 degrees. I will have in this direction tensile stress of tau and in this direction a compressive stress of tau. Okay. So, there will be equal magnitude of tension and compression coming in this stress state, which is a pure stress state in a 45 degree plane to the coordinate system in which the stress tensor had a representation similar to this. Okay. So, another representation of this stress tensor is tau 0 0 0 minus tau 0 0 0 0. Okay. So, what we are saying is there exists only a one plane, at least one plane in which there are no normal stresses, that is the key word. Okay. There is only one plane in which there are no normal stresses. There might be other planes in which normal stresses will occur, there will be planes in which there is no shear stress, even though the state of stress is a pure shear. So, do not get confused by the word pure shear to mean that there exists no plane in which normal stresses occur, there will be only one such plane, because the principal stresses will always be there, in which plane there will not be any shear stresses. Okay. So, you have to understand that even though we call it as a pure shear stress state, it means only one plane in which there will not be any normal stresses and there will be only shear stresses acting on that plane. Okay. The next stress state that we are going to look at is what is called as a deviatoric stress state. This is noted by sigma deviatoric. This is nothing but sigma minus trace of sigma divided by 3 times identity. You will note that trace of sigma deviatoric would be trace of sigma minus trace of sigma by 3 times trace of the matrix 1 0 0 0 1 0 0 0 1, which would be 0, because the trace of this matrix is 3, this 3 and this 3 gets cancelled. So, trace of sigma minus trace of sigma gets cancelled. So, trace of deviatoric tensor is 0. Okay. So, basically deviatoric tensor is defined as this matrix sigma minus trace sigma by 3 times identity. What this tells you is, this gives you the components of stresses that causes distortion in the body. This stress causes distortion or angle changes in the body. Okay. In contrast to this, you add the hydrostatic pressure or hydrostatic state of stress. Okay. In contrast to this, you have hydrostatic stress, which will cause no distortion, but only volume changes. In the body if volume change is possible. Okay. There are bodies whose volume won't change due to the application of hydrostatic pressure. Such bodies are called as incompressible bodies. Okay. So, basically now hydrostatic pressure is the one which causes volume change, deviatoric stress is the one that causes changes in angle or distortion of the body. Okay.